right? Thank you so much for joining the talk today. I'm Sahar, I'm a sales engineer at Hummink, and today I will be presenting and talking about the sub-micron printing breakthrough. So to begin with, it's really important to give you a bit of summary about our company. So Hummink is a technology provider. We provide a technology called HPCAP, High Precision Capillary Printing, which I will detail in the video in a few minutes. The company is a spun-off from ENS, École Normale Supérieure in Paris, and currently has its headquarters in Paris and key regions in different areas of the world. In less than 2 years of existence, Hummink was able to sell its R&D equipment and is currently in advanced discussions with equipment makers to reach high-volume manufacturing by the end of next year. So as I mentioned, Hummink is a technology provider, so we provide the printing tool as well as its consumables, the pipettes and the inks. So to know more about HPCAP, it's really inspired from AFM, atomic force microscopy. You have the pipette that you see, which we fill in with ink. And as you will see in this video, the pipette is attached to a tuning fork that resonates at a fixed frequency. Once this pipette approaches the substrate, contact is detected and there is a frequency shift. This enables deposition. And once the pipette is lifted, then of course printing stops. And for you to be able to print continuously, you just have to maintain the contact between the pipette and the substrate. And thanks to capillarity, you are able to adapt to the surface roughness and topography, as you can also see in the video. What we can print is simply anything, from dots to lines, even filling holes. You have the full freedom of design, whether you want to draw from the software or import your design, with unique precision without any splashing, any dropping at all. 0% material wasted. And that's why we are able to do such submicronic gaps reaching less than half a micron. We can also do some 3D structures like this, like the 3D bumps that you can see over here. So we do it in a very controlled one step by which you can control the dimensions very well. You can control the size, the diameter of your bumps, even reaching very high aspect pilers. As you can see, we've reached 20:1 piler, and we can even do beyond that. So here are the pipette's diameter. We have a resolution between 50 micrometers up to 100 nanometers. And what we can print with are different kinds of inks, metals, polymers, quantum dots, from low to high viscosity on different substrates. Our tool, of course, can be used independently and, if needed, integrated into other systems. So this is, in a nutshell, the technology and what we can do. And I will elaborate more on the submicron part in the next few slides. So first of all, a key differentiator of our technology, if we compare it to traditional printing techniques, is the resolution. So 50 micrometer up to 100 nanometers. So we are really at the submicron scale. And the inks that are being used can be of very low viscosity, like water, up to very high viscosities, 100,000 centipoise and even beyond that. But what we've tested is 100,000 centipoise. Of course, in addition to the key differentiator of precision and the fact that we print by capillarity without the need of applying any pressure or any other external energy source. Of course, there are some common sense physical boundaries that we have to take into consideration in order to mitigate. Number one will be rheology. So we can reach very high viscosities, but of course, printing like gelish materials would be difficult. Second thing is, in case we use particle-free inks, that's perfect. In case we use inks with particles, which is completely normal, that's what we normally do, we just have to make sure that these nanoparticles are actually, their size is actually less than 10% the diameter of the pipette in order to prevent any clogging or jamming. And finally, if we deposit very hydrophilic solutions on hydrophobic solution, this might affect the resolution, and we have to take that into consideration. Now let's talk about submicron printing. So why is submicron printing important, and why it's important today? Of course, it will be important in the future, but today is what you have to think about a bit more nowadays. So it is important today because we're leaning toward miniaturization. We want everything to be actually smaller. Second, we want to enhance the performance of device. That's why we want the submicron printing to do that. Third, when we talk about packaging, for example, we want higher packaging density to improve the performance and the memory, so we also need submicron printing. Of course, technologies emerge